Hello everyone, welcome to VLSI Career Craft. So previously we have seen a couple of examples on static timing analysis where we have calculated the clock skew, and based on the clock skew we have calculated the minimum clock period. So in this example we will go furthermore on hold violation and how to fix this hold violation. So let's get started. So in the question it is given that a synchronous system has T setup, T hold and T clock to queue as a 40 picosecond delay, and there are two combinational logics which has T max and T minimum delays given. So in the first part we were asked to calculate minimum clock period in case of the no clock skew. So there are two paths here, flip-flop 1 to flip-flop 2, and second path is from flip-flop 2 to flip-flop 1. And in the second part of the question, it is given that there is a positive clock skew of 30 picosecond between flip-flop 1 and flip-flop 2. That is in path 1. So we were asked to check if there is any hold violation here, and if there is a hold violation, how can we fix it? So first let's solve the part A. Yeah. So here there are two cases. Case 1 is this and case 2 is this part. There is a equation where we calculate a T clock minimum clock period. So let's substitute the values. T clock to Q is 40 picosecond and T combinational delay max is 590 picosecond for combinational logic A, and T setup is also given as 40 picosecond, which is less than T clock, plus there is no clock skew, so clock skew is 0. So that gives us T clock is greater than or equal to 670 picosecond. This is for path 1. So let's calculate for path 2. 40 picosecond plus the combinational delay max is given as 565 picosecond plus the setup is again 40 picosecond, which is less than or equal to T clock plus there is no clock skew. So that gives us T clock should be greater than or equal to 645 picosecond. That is for path 2. So in these two cases, we consider the worst case. So worst case delay is this. So that gives us minimum T clock is equal to 670 picosecond. So let's get into second part of the question where the positive skew between flip-flop 1 and flip-flop 2 is given as 30 picosecond. So in case 1, we use this equation to solve to check if there is any hold violation or not. So let's substitute the values and see. T hold is given as 40 picosecond plus T skew is given as 30 picosecond, which is less than T clock to skew 40 picosecond plus minimum delay is 20 picosecond. That gives us 70 picosecond less than or less than 60 picosecond, which is not true. So there is a hold violation here. So let's check for the path 2. Here flip-flop 2 becomes launch and flip-flop 1 becomes capture flip-flop. So when there is a positive clock skew between flip-flop 1 and 2, there exists a negative clock skew when the path is reversed. which is equal to minus 30 picosecond. Now, on substituting the values, in this case also we have T minimum as 20 picosecond. So that gives us 10 picosecond less than 60, which is true. So there is no hold violation in part 2. So how do we fix this hold violation which exists in part 1? Let's see. So there are two ways we can fix this hold violation. If you observe this equation, we have two quantities which are fixed and which we cannot change. Those are T hold and T clock to Q. So we cannot do anything about these two. So the only quantities we can change is T skew and T combinational minimum. So in this case, the T skew is already fixed, which is positive skew between for 1 and 2 and negative skew between 2 and 1. So the only quantity we can change in this case is T combinational minimum. So for this equation to be true, the right hand side part should be more and left hand side part should be less. So we need to increase the combinational minimum. So let's assume that there is a delay of delta which is added to path 1 in order to fix this hold violation. So let's substitute the values again. T hold is 40 picosecond plus T skew is 30 picosecond, which should be less than T clock to Q, which is 40, and T combinational minimum is 20, and there is additional delay delta. So we need to find what is this delta value. Delta should be greater than 10 picosecond. So when we add a delay in path 1, which is equal to delta, this delta value should be greater than or equal to 10 picosecond to fix the hold violation. So the minimum delay that can be added to path 1 is equal to 10 picosecond. It can be more, but the minimum delay that needs to be added is 10 picosecond. So that solves the part 2 of the question. So in this question, we have understood how to check the hold violation and how to fix it. So in next example, we'll see more further advanced concepts, and yeah, follow us for more content and follow us on Instagram VLSI Career Craft and subscribe to our channel. Thank you so much.